it. My name is Maarten Mayo. I'm from Antwerp, so I'm pretty lucky that I wasn't stuck in traffic today for once. I work for Real Dolman, and I'm the co-founder of the Windows Azure user group in Belgium. So if you're interested in Windows Azure and everything related to Windows Azure and cloud computing, feel free to go to azug.be and register and join us. My focus is on web, so everything related to ASP.NET, ASP.NET MVC, Windows Azure, PHP, and if possible, a combination of all is what I'm really interested in. I blog about that on my blog, which is on the slides. And if you follow me on Twitter, you will probably see a lot of tweets that don't mean anything, but also a lot of tweets that try to focus on the technologies I try to spend my time with, so ASP.NET, Azure, and stuff like that. So the agenda for today. First of all, I will give you a quick overview about the difference between cloud computing and between a traditional architecture on traditional hardware, data center, stuff like that. After that, I will go into the different metrics. So for the virtual machines, for storage, for SQL Azure, for data traffic. And I will also give you a small clue about developer awareness, because your developers will actually be, well, quite in charge about how your application will behave and how much your application will cost on Windows Azure. So it's important to keep your developers aware as well. And after the session, we have some Q&A, but feel free to talk to me anywhere in the venue if you spot me on Azure. It's really interesting to talk about. It's really interesting to work with Azure, so feel free to come over. So different metrics between a traditional architecture and Windows Azure. There's some differences. You probably know this slide because it's in like every slide deck on Windows Azure. So I'm not going to make the full explanation of it, but what I want to focus on is these staircases. You see the staircases in the yellow line, where you invest every time in new people, in new hardware, in new data centers, new servers, new whatever you want to do with your server park. And that's not the ideal model, because you see the blue line, your load. It will fluctuate, but in general, you have way too much overcapacity, so you pay a lot in your own data center, and sometimes you may have undercapacity. Now, this is leveraged better in Windows Azure, where you pay for use. So you will try to stay as close to the actual load as possible, not do investments, but it's important if you want to stay close to this load that you know about the billing and the implications your actions in your software development can have on your bill at the end of the month. So, should have removed the animations there. So, the main difference is the cost model versus the investment model. So if you have your own data center, you do investments in people, in hardware, in software, all these licenses, security, stuff like that. And while with Azure, you just pay for what you use. So it's important to know that difference, because if you do an investment, it's there. But if you have a bill at the end of the month, you will want to wait for that bill, and you don't want to use too much capacity. And you can compare it with the lasagna you see on the slides. Imagine you have bought one server, or two servers, or a whole data center, and that's the bowl containing the lasagna. In a traditional architecture, you will build your application and throw in some layers, some extra lasagna, and you can keep filling the buckets until the bucket is full, and you have a wonderful lasagna. Now, you have the capacity of the bowl. The bowl is there, so you can fill it. You can add components, you can add an additional layer or an additional service somewhere, or hide some scripts on the server because the bowl is there. Now with Azure, you don't have the bowl. Basically, you just have a plate, and everything you stack on top of that, you will pay for it. So the difference between Azure, between the operational expenses and the investment model, is just that you have a bowl versus a plate with lasagna. So in cloud, you really don't want to add extra layers if they're not needed. You don't want to add extra traffic between components in your application if that's not needed, because that will be on the bill at the end of the month. So it's important to focus on that while designing your application, because your design has real implications on your cost at the end of the month. So with Windows Azure, I'm not sure how many of you are familiar with the pricing model. Okay, a few. Well, basically what you pay for in Windows Azure is the services that you use. So for example, if you're using Windows Azure, you will pay for compute. So pure computational power on Windows Azure. You will pay for the virtual machine. You will pay for the usage of the virtual machine. That's it. You will also pay for storage. If you want a larger blob storage to store your files, you will pay more. If you use less, you will pay less, of course. Also for the storage transactions. If you have blob storage, for example, and you host the images of your website on that, and you have a lot of concurrent requests, you will have a lot of transactions, and the transactions will cost in that case. And there's differences that you can make between all these prices just by selecting the right component for the right usage. For SQL Azure, you just pay for the database, so just for the disk space used by the database, which is also very interesting. I will cover that later in this talk. With Azure App Fabric, you will pay for example, for access control transactions. So every time a user logs in to the access control service, you will be paying a transaction there. So that should not be too much, but it's a cost to consider. Also, you will pay for service bus connections. So the service bus is really interesting if you want to connect application components, but if you connect too much, and if you just think, well, I can combine everything in this App Fabric pool, you may be paying way too much, and you may have to think about restructuring your architecture to have less costs there. You also pay for data transfer consumed with all of these components. So if you use a virtual machine or storage or SQL Azure or App Fabric, all the data that goes across the wire, you pay for it. So it's important to know the fact that you are being billed for ingress, so incoming traffic to the Azure data center, and also for egress traffic, so for outgoing transfer out of the Azure data center. It's important to know this because if you have two data centers in use for Windows Azure, for example, North America and Europe, you will pay for traffic between those two Azure data centers, while if you keep your storage and your compute in one data center, you will not pay for traffic within the data center. So it really depends on how you structure your application, how you architecture it, on what the bill at the end of the month will be. So that's 8 different parameters on the previous slide. Who thinks that's much? Okay, a lot of you. I'll show you it's not much. Typically, you will only use 4 or 5 of these parameters. So simple applications will probably only use compute, maybe some storage, maybe SQL Azure, and probably, if the application is being used, also data traffic. Now, if you have your own data center, it's slightly more complex, in fact. I've been doing some research there. You have licenses, you have hardware investments, maintenance. It's really a lot of costs and a lot of different factors that you should account for. But the problem there is you just pay it and it's there and you have the capacity. So it's really the difference in models that makes actually this one more complex than cloud computing, in my opinion. So easing the bill was the introduction. Let's go to, well, make the bill less or more cheap at the end of the month. First of all, with virtual machines. Try to limit your virtual machines. If you do a deployment, check if all the servers that you deploy are actually being used. Do you need your full capacity 24/7? If you deploy like 4 servers in Windows Azure, chances are, if you target a Belgian audience, for example, that during the night you will not be needing 4 servers. Scale down during the night. It's a reduction of costs. Your application will cost less and will be more cost effective during the night. And you can just do that yourself using the Diagnostics API. So there's an API for that in Windows Azure, which you can call from PowerShell, from Visual Studio, from tools out there, from PHP, from Java, wherever you want to call this API. Just scale down when you don't need them. You shouldn't, well, you can do auto-scaling, but you can also just say, well, during these office hours, I need more instances. During the other hours, I need, well, less instances. So there's a pricing example there. If you have 24 hours of 10 small instances, it will cost you 20 euros per day. If you have 16 hours of 10 instances, and then 8 hours during the night, where you scale back to 4 instances, it will cost you 16 euros. It's not much per day, but it can ease the bill. It can make resources available for other stuff in your project as well. Your staging environments. Who was aware that you have a staging environment on Windows Azure? Okay, a lot of you, that's good. your developers can deploy to the staging environment. Now, developers are usually in the office, well, some at night, some during the day, but you will have a period in a day where the staging environment is not needed. So just remove the deployments during the night. Don't pay for the deployments if they're not used by your developers. It will save on the bill. There's another pricing example there. Well, if you just use 12 hours or 22 hours of the instances instead of 24 hours, you will pay, well, half the price. So I will give you a demo about how you can do this. I give you one demo from PHP, where you can scale your Azure solution from PHP. Well, I will not be scaling from PHP because it takes a while to do that, and I want to show it from two different angles. But I will just call the management API and do a reboot on my Azure deployment, and then I'll use PowerShell to scale my solution. So let's go to my command line, and I have a PHP script here. I will just issue one script, PHP reboot.php. Let's go. And if I now go to my management interface for Windows Azure, you will see that this deployment has one instance currently, which is this one. And you will see that it will start rebooting once the data is refreshed. So currently it says ready, and it should go to, well, initializing when it's rebooting. So let's wait for that, refreshing data. It does take a while on the network. And actually this script is pretty simple. I'll show you the script first, because it takes a while to run, apparently. The script is pretty simple. It's just using the Windows Azure SDK for PHP, where you can just use a management certificate. So you have your certificates to connect to this API, which is this one. Then you use the classes for connecting to the management API, and you just say, well, I want to reboot this role instance in my production slot. So that's everything you have to do. Scaling is similar. You just say scale to 1, 2, 3, 4, whatever number you want to scale to. So it's really interesting to do stuff like that and just have some scheduled task somewhere in your company, undeploying or, well, scaling down at certain hours in a day. Same thing can happen. By the way, I will have another look at the management portal. It's still refreshing data. This takes a while. Okay, there we go. So now it's no longer ready. My instance is rebooting. So you see it's preparing the node. I've just rebooted from PHP. You can do the same from PowerShell. So I have a PowerShell script here where, again, I have to enter my subscription ID. So the management API knows which subscription I am and who should be billed. Then I am also loading a certificate. So I should connect using a certificate. And then I say, well, I want the production slot of this service. I want to set a different deployment configuration there. So what I'm doing is just uploading a new configuration to Windows Azure through PowerShell. So let's do that. And it will also take a while to do. So in the meantime, I will show you the different configuration. So first of all, I have the service configuration here, which I apparently can't open from Explorer. So just a second. So the initial service configuration will just be the XML that I deploy to Windows Azure. And what's in there is just instance count is 1. So my configuration tells Windows Azure to only deploy one instance of my application on Windows Azure. So let's open that in Visual Studio. That's not what I meant to do. Really annoying if it doesn't work. Let's go through there. So the default configuration is just what I deploy to Windows Azure initially. And it contains an instance count of 1, so this value. And if you want to scale in Windows Azure, you just increase or decrease this value, and the data center will automatically change your deployment that's currently running. So what I'm doing here through PowerShell is basically uploading the other configuration where I say the instance count is 2. And if I now go to my portal on Windows Azure, you will see that the second instance is also starting. So I just scaled up from PowerShell. And you can also script this, you can also schedule this, and do it at night or whenever you need less or more instances during the day. I'm going to close that one because I'm really too stupid to use the magnifier. Let's go back to the slides. So, another thing you want to consider is worker roles. Who has tried to create a worker role in Visual Studio? Okay, a few. If you open Visual Studio, you get this, well, a bit of like the feeling that Microsoft wants you to just write one task per worker role. It's just one method that you get where you should do your work and have the worker role executing. And it feels like you only have one place of code, and your worker role can only accomplish one task. Now, if you look at that, if you have a solution where you have 10 tasks and you want to be covered by the SLA of Windows Azure, you actually need 20 worker roles running concurrently to do one task per worker on 2 machines. So 20 workers. If you can scale that to 2 workers per machine, you only need 10 workers because you can just cut off half. Now, what if your tasks are so tiny that you can just deploy all tasks on 1 or 2 worker roles? Well, you scale down from 20 workers to just 2. So it's an important cost difference where you pay 41 euros per day when you're using 20 worker roles. But if you can compactify your tasks, so put the 10 tasks on 2 workers, you only pay 4 euros, which is a significant difference, I think. There's also added the URL on the slides, which is a generic worker example built by Microsoft, where you can just add assemblies, and you have some generic worker roles that will pick up these assemblies and execute the tasks in there. But I will give you a feeling about how you can do this. So, I'm out of battery. I don't know. So, if you open your Visual Studio, again, you can see that in a worker role, you typically have, let's see if it works. Yes, it works. You typically have one worker role with a role entry point, which is this one. Zooming in. And you get one while-true loop where you have to do your task. So typically, you write one task in this worker role, and Microsoft basically has caught you and pushes you to doing one task per worker. Now, what you can do is just use threading or spinning up new processes or use the parallel library just to execute all the tasks in your solution. So what I have here is I'm using MEF to load some tasks, and I have 2 tasks. One that sleeps for 2 seconds, and one that sleeps for 3 seconds. And while true in my worker role, I'm just executing them, waiting, re-executing them, waiting, re-executing them, and stuff like that. So if I run this, you will see that my one worker is actually now doing 2 tasks in different threads. And you can, I don't know the ideal number of threads per worker, but you can, well, basically try it out, how you can scale your multiple tasks on 1 or 2 workers instead of using way too much worker roles there. So let's have a look at our Windows Azure deployment in the compute emulator. You will see now, once this machine has booted, that it's doing 2 tasks. So my sample task implementation 2 is 1 task, and my sample task implementation 1 as well. So the order in which they are executing, well, you can determine that, but in my simple example, I didn't do that. You can just run multiple tasks in one worker without a problem. So let's close that one. Okay, do you need all of that? So you have different sizes, like t-shirts in Windows Azure. You have smalls, you have mediums, you have large and extra large. It might be tempting to just take one extra large for every application you're deploying. Might be tempting, and it's basically what you typically do in a data center environment in your company. You go to internal IT, it takes a while, so you just order the biggest server that's out there. Don't do it on Azure. Only use the larger instances when you actually need them. So the larger instances have multiple CPUs, they have more memory and more storage in the machine itself. If you don't need much storage on the disk, and you don't need a large CPU and much memory in the machine, just to use smalls. Why do you want to do this? Well, one extra large is 8 times the price of one small. So this means that if you want to scale or just run covered by the SLA, you want to run 2 extra large instances, which will cost you 16 times the price of a small instance. Which means if you want to scale that, it's difficult to do that very granularly. While if you just deploy smalls, you can just go from 1 to 16 and somewhere in between there to, well, really match the actual resources that are needed by your application. So it's really important to just pick the right instance size when building your application. Unemployed? Well, undeploy it. If you have workers or web roles or whatever in your solution that's not being used, undeploy it. So for example, the staging environment. If you're not using the staging environment, undeploy your application because you're paying per reserved virtual machine hour. If you upload your virtual machine to Windows Azure, and you have 1 or 2 virtual machines sitting in there, not running, turned off, powered off, you actually pay for them. Because you're actually using capacity in the data center, you have a virtual machine deployed, but it's just not running, but you pay for it. So if you have something that's not running, immediately delete it, unless you want to restart it in like 10 minutes or something like that. So undeploy when not needed, and this is for staging, this is for production. Don't keep stopped instances in your deployment because it will be built. So there's a tool for that. If you're doing, well, staging environments, for example, there's a tool called Greybox, which is a small task tray application which will remind you every few minutes about the Azure deployments that are running in your Azure subscription. So mine just fired off. And it will show me, once it fetches the data from Windows Azure, it will show me that I have a few deployments running on Windows Azure. There it is. I have 3 deployments. And if I leave the office as the last developer, I can just say kill active deployment, select the one I want to undeploy, and Greybox will undeploy it and remove it, so no costs are incurred. You can find this tool on Codeplex. It's really useful if you're doing development and you want to, well, undeploy and delete instances whenever you have finished working. So, well, usually in the previous portal, there was one saying that we had: when the box is gray, you're okay. When the box is blue, a bill is due. That's the fact. If you have a deployment that's stopped, the box is blue. So every time this image in the portal is blue, you're actually paying for the deployment that's sitting in there. So keep this in mind when doing Azure deployments. Work per hour. Virtual machines are built per clock hour, so not for the CPU usage that you're doing, not for the amount of time they are deployed, they're built per clock hour. So this means if you deploy at 12 and you run your application till 1, it's built 1 hour. If you deploy at 12:30 and you run till 1:30, which is in essence also 1 hour, it will be built for 2 hours because it's 2 clock hours that have passed between that period. There's a small exception there, like 5 minutes before every hour you can deploy, well, free, you get those 5 minutes for free. But be careful not to deploy, well, at bad moments. If you deploy at like 50 minutes after the hour, it's a bad idea because you will be paying for 2 clock hours while you actually used just one. Also, don't deploy every minute. It might be tempting if you have continuous integration and continuous builds to just push a new Windows Azure deployment to Windows Azure every time a build is finished. Well, if you do that with continuous integration, and you have, let's say, 1 check-in every minute, which means you will have 60 deployments during that hour, you will actually be paying for 60 clock hours because you did 60 deployments, you spinned up a virtual machine for 60 times during that hour, you will have a lot of money lost there. So accumulate your check-ins. Don't do continuous integration too often, or continuous deployment too often when running on Azure. Be smart about it, and your bill will be lower significantly. Okay, so bandwidth and storage, also an interesting one. We Belgians, we are quite used to being limited on that, so you will probably think about that when deploying to Windows Azure as well. And it's a very simple metric. If you use more bandwidth, if you use more storage, you will pay more. If you use less of them, you will pay less. So it's really simple. When are you using bandwidth? Well, if you're doing data transfers in and out of Windows Azure. So if someone visits your website that is hosted in Windows Azure, you will pay for the incoming traffic, so the HTTP requests that are coming in, but also for the data that is being sent out. Not if you're within the same data center. So if you have a storage account and a Windows Azure compute account sitting in one data center, you won't be paying for the traffic between those. But if you have a storage account, for example, in North America, and a deployment running in Europe, you will pay for the traffic between both. Also, what you can do is use your blob storage or the content delivery network to host your files, your images, your CSS, whatever you want to host on there. You will also be paying for traffic between those. You will also be paying for SQL Azure traffic. So again, if you have your SQL Azure database in the same data center as your Windows Azure solution, you won't be paying a thing for the transfer between both. But if you have a SQL Azure database sitting somewhere centralized in Europe, and you have a deployment running in the US, one in Asia, and one in Europe, you will be paying for the amount of traffic that's being sent over the wire to the SQL Azure server. So keep in mind, be smart about it, and try to concentrate all these things together. Windows Azure has an interesting concept in helping you define your architecture. The idea is that if you place your SQL server somewhere in a different data center and your compute instance in another data center, you will be paying for traffic, which means that Azure thinks this is a bad idea to do because you will have higher latencies between your SQL Azure database and your application itself. So it's better for the application to have them close together. And, the fact that you're built for it is an encouragement for you to think about that and put those two together in one data center. The content delivery network. Who knows what a content delivery network is? Okay, most of you. For those who don't, it's just distributing your files across different servers around the world. And every time someone retrieves an image, for example, Twitter does this, Facebook does this. When someone retrieves an image, it will come from the server that is closest to you, and which will be able to serve you the fastest. So the image that you can grab the fastest is the one being delivered to the clients that are using your website. Now, if you use the content delivery network, you can tell the content delivery network to just mirror, to replicate, to cache all the public blob containers in your blob storage account, which is, maybe a bridge too far. Maybe you want to limit that and just have a few blob containers replicate to the content delivery network. So think about which blob containers have to be public and not, because the content delivery network will copy those and will be paying for storage 2 times. So once for having the files on blob storage, and once for having the files on the content delivery network. Also, the data traffic between all the content delivery network nodes and your blob storage account is being built. So this means that I think there's currently somewhere above 20 edge nodes for the content delivery network. This means that every file is being fetched like 20 times. So think about it. Don't make everything public. Don't push everything into the content delivery network because it will hurt you at the end of the month. Also, what you can do, there may be images like your company logo. It doesn't change that often. So what you can do in blob storage is setting a cache expired header on that image, and the content delivery network will use that cache header to decide on whether it should refresh or not refresh the logo. So if you put a cache expires header of like 1 year on that company logo, the content delivery network will only fetch it once and keep it for a year cached, so it won't be refetching too often. And that will also save you on the bandwidth bill of these things. Okay, storage. Well, the non-SQL storage, so non-SQL Azure, table storage, blob storage, and queue storage. You pay for the data you store. So the amount of data you store is being billed for, per gigabyte per month. But it's an average, which means if you store 10 gigabytes for 15 days, and then remove all data, you will be paying for like approximately 5 gigabytes, because it's averaged. This is interesting because if you want to host a large file for a short amount in time, you can just deploy it to blob storage, have your users download it, then remove it, and you will not be paying for the full amount of storage you have used for maybe that 1 or 2 days. So it's being averaged, and you can basically profit if you keep in mind that if you remove certain files, you will be paying less. Okay, transactions, also an interesting one. This is really the cheapest cost in Windows Azure. You're billed per 10,000 transactions. So this means if you have one file on blob storage, one image, for example, and that image is being fetched 10,000 times, you only pay like 1 cent, which is not much. But consider a queue where you have two worker roles continuously polling a queue, fetching data from the queue, checking if messages are available. If you do that for one day from two workers, you have almost 200,000 transactions. Still, not too much of an amount that you will be paying, but consider a month of those and consider 10 workers or 20 workers or different tasks, different queues. The storage transaction count may be high at the end of the month, and your bill will also be high. So basically what you want to do is using a back-off mechanism. Checking the queue. If data is available, process it and recheck it. If you check the queue and no data is available, you wait a second. Then recheck the queue. If no data is present at that time, you wait another second. So you wait 2 seconds in total. Refetch, you wait 3 seconds if no data is available. And you will have less transactions that way. Now, once a message is available, just reset the counter and keep checking continuously, because that means that more work is available at that moment. But do back-off polling, that's what they call it, and you will have, well, much less transactions per day and much less transactions on your queue that you will be billed for. So let me show you how you can do this. It's actually really simple. So again, I have my worker role with different tasks, and I've refactored it a little bit. Let me open the solution. What I have there is a worker role that is, well, for every task it finds in my solution, it's running that task. So again, I'm combining multiple tasks in one worker role and executing them simultaneously, well, if possible. And these two tasks are one fill queue task. I'm going to close Greybox, by the way. One fill queue task, which will, well, every time it's being called, it will just enter some random messages into a queue on my local development machine. This will run. It will say I'm running, and while it's running, it will never be run twice during the same moment. It will just add some messages to the queue. Then I have another one, the process queue, which will be polling the queue. So what I've done here, I'm connecting to my development storage account, connecting to a queue named sample. And then I have two variables, the current backoff and the maximum backoff. So current backoff is the, well, the amount of time that I want to wait between two polls on my queue. So what I do is, while true, fetch 10 messages from my queue. If there are messages available, I will reset my current backoff, so make the time I want to wait afterwards, I reset that to 0. Then I go through my messages, process all these messages, and, well, delete them when they are processed. Now, if no messages are available, I check if my current backoff is still below the maximum backoff that I have, because if you don't have a maximum backoff, it may be that after a year or so, your thread is sleeping for a year. And when a message arrives, it takes 1 year to process it. So you don't want that. You want to have a maximum in there where you want to account with, and keep that really as the maximum backoff in your application. Next, well, I increase it if nothing is available. And after that, I sleep for an amount of time in there. So if I run this, let's hope we get some nice results out of that. But you will see it will be sleeping. So every time it's sleeping, I'm pushing a message to the console of my Windows Azure role that's running, so you can see what's happening behind the covers. So let's go in there. There we go. You can already see. So my fill queue was doing work, so it was pushing messages onto the queue. And after that, my process queue was being called, and it was doing work. But after that, the fill queue maybe just has entered 5 or 6 messages. After that, my process queue fired again, found no messages, is sleeping for 1 second. And if I have a look again, it will say I'm processing messages. But again, my queue has no more messages. It's backing off for 1 second, checking again, backing off for 2 seconds because no data is available. If you do it like this, and I know there's someone in the audience who had a surprise like this, Eve. If you do it like this, you will have a much cheaper bill instead of just continuously polling your queue. So, just in case, I had a slide prepared where I would be showing you. So, again, here you can see that if messages are available, it will process the messages. If messages are not available, it will back off for 1, 2, 4 seconds whatever time is required just to wait for new messages in the queue. Okay, so transactions. We had the queue transactions for checking your queue, but there's also an interesting one there regarding blob storage. Microsoft tells you that you can put your images, your static content of your web application on blob storage, which is very interesting because blob storage is cheap for storage. Now, if you have a high traffic website, you will also be billed for transactions. So every time a user fetches your image from your blob storage account, you will be billed for one transaction. Now, if you're Facebook or Twitter or whatever large application, well, it will be a lot of transactions of people hitting your blob storage account and fetching images there. So in this case, while storage may be cheap on blob storage, your transactions will be very high and you will be paying a lot of money in transactions. So the better choice there is, well, not to push your content on blob storage, but instead just keep your images, keep your JavaScript files on your compute nodes, so on the actual IIS web service running in Windows Azure. Because that will be cheaper in this case because you don't have the transaction cost. You will still have the traffic cost, but that will be the same one like the one you would have in blob storage. So the better choice here is use compute for that. Also, the diagnostics monitor. Who has played with this one? It's really, you can have your deployment running on Windows Azure, and you can configure some process counters, you can configure IIS logging, event logging, stuff like that. And all this data is collected and then copied to blob storage every once in a while. So all this process counter information is copied to blob storage. Now the diagnostics monitor only does the copying, so it will well, monitor a process counter, yes, a performance counter. It will monitor your logging, and it will copy all this data to a blob storage account. Now, it only copies, it doesn't delete this data. So if you have a deployment running for 1 year, and you don't clean up the data that's in your blob storage account, considering diagnostics, well, you will pay for the storage it uses. Also, if you write a lot of times to your storage account, and if you have a lot of nodes running, and you copy this data continuously, you will see a large number in transactions because the transactions between your diagnostics monitor that's uploading this data to blob storage and blob storage will be quite high in this case, so you will pay for that. So try to write a little bit less, but this will give you a bit of a lag in diagnostics data. Now, if you don't need the diagnostics data too much, and you can live with the fact that diagnostics data is like from 15 minutes ago, you can do it. Write a little bit less, have less transactions, and less data traffic across the wire to your blob storage account. Okay, SQL Azure, another interesting one. SQL Azure is pretty simple conceptually. You have some database editions. You have a web edition of 1 gigabyte and 5 gigabytes, and you have a business edition of 10, 20, 30, 40, and 50 gigabytes. All these things have different pricing, but it's all, well, every increase of 1 gigabyte costs the same. So it's always around $10 per increase of 1 gigabyte. So if you have 1 gigabyte, it's $10. If you have 5 gigabytes, it's $50. Pretty easy, no decreasing costs there. Plus your data transfer, of course. So this means if you deploy a database of 1 gigabyte, you will be paying 10 euros or 10 US dollar per month. Now, this billing is based on peak database size per day. So again, like with blob storage, if you have well, a database that has like 1.5 gigabytes in a database for a few seconds, and then falls back under this 1 gigabyte limit, and you have only 1 gigabyte of database, you will be paying for 1 gigabyte of database. But that's only possible if you take a 5 gigabit database, because after you reach the 1 gigabyte limit, you will be put on read-only. So if you have 1 gigabit database and you have a moment where you have more data to put in that database, you will be put on read-only. So what you can do there is just choose for the 5 gigabyte version when you know you will be always below 1 gigabyte, because you will only be paying for 1 gigabyte in that case. You subscribe for 5, so the portal told you would be billed for $50 a month. But if you're using less than that 1 gigabyte averaged per day, you will be only billed for that 1 gigabyte. So if you know your database size is somewhere around the turning point between both database sizes, pick the higher one because you will pay for the lower one if you, on average, stay below that lower size. Also, tables and indexes cost money. So if you have a large table on SQL Azure, you can do that, no problem. You can query the table, but if it's like data that you don't use that often, and have 20 gigabytes of data stored in SQL Azure, you will be paying a high amount for those 20 gigabytes. While if you would copy that data to table storage, for example, it would cost you 12 cents per gigabyte instead of $9. So that's a significant difference. If you have data that you're not using that much, just copy it to another storage option, which will, well, of course, table storage has less querying capabilities, but you can just use table storage instead of SQL Azure, because that will give you, well, way less costs. Also, every index costs money. So if you, well, I see a lot of developers doing this actually. They put indexes on every column in every single table. It's not smart because the query optimizer will not be using it in many cases, but the index is still there. There's storage required for this index to exist within SQL Azure. So think about your indexes as well. If a large table and a large table index would cost you €1 or $1 per month, while that's not much on your bill, it may be better for your code to just remove that index if you're not using it. Again, this is an example of where Azure bills you for bad behavior. If you have an index that's not being used, you will be billed for it, so it's better to remove it in that case. And keep in mind that if you have large data sets you don't use often, just copy them to blob storage or table storage or wherever. So I will give you a quick demo. I found a nice query on the internet, actually approximating the cost of my SQL Azure database. So if you go to the billing portal, you will only see well, one cost at the end of the month, which is if you have 1 gigabyte database, you will see that $10 will be billed on your bill. If you want to know which tables are consuming most of that money, you can just use all the management views that are available in SQL Azure to, well, basically calculate the cost of each table, of each index, of each view that's available within your database. So this is what I'm doing here. For example, for the TechDays live feedback application, these are the tables, and you can see the costs. Now this cost is not, well, completely what you want. For the lower tables like survey, this will be correct. It's using like 16 kilobytes of data. Costs not much. If you have a look at the tenant user table where your batch IDs are stored, you will see that it almost costs $4, while it's still only 200, well, almost 300 kilobytes. This is because well, SQL Azure will reserve data. It will see, well, this table needs more data. It will reserve the data and increase the number of bytes used there. So that's the fact that you're seeing. So it's not completely reliable, but it can give you an idea of the cost of every table, of every view, of every index, of every stored procedure in your database. And some cost a lot, and when they're not used, just discard them, don't use them when they are no longer needed. Okay. Also, one extra interesting one is stored procedures. Who's using stored procedures in their coding? Okay, good. Not too many. Who's not using them? Just checking who's asleep. I was not asleep. The guys who are not using them, if you move to SQL Azure, it may be interesting to use them. Because if you look at the pricing model for SQL Azure, you're only paying for storage. You have 1 gigabyte of data, you pay for a 1 gigabyte database. You don't pay for the CPU. So it may be interesting to write some extra stored procedures there, put some more logic in your database, because the computation power in there, while it's limited, but it's free computation power that you're not using on your virtual machine. You can maybe scale 1 or 2 instances down by just using stored procedures in the database. So it's an interesting concept. You can do all the complete amount of calculations that you would normally do in a worker role in a stored procedure on SQL Azure, but you can leverage it to run stored procedures if you want. So it's an interesting concept that you can explore. Okay, Developer awareness, also an interesting thing. Well, I've talked about some of the development points already. So if you have a lot of indexes that are not being used, just slap your developers and remove the indexes. Because when you don't need them, you don't want to pay for them. Also very interesting is this one. I have a code snippet of an ASP.NET MVC application where I'm using sessions to store the language a user has selected. And I'm using the table storage session provider that's available for Windows Azure. So if I deploy my application to Windows Azure, my session data will be stored in table storage. Now, you see this code. I'm checking if the language is English, then doing something. Then I'm checking again to check if the language is Dutch. And then I'm doing some more code. Now, have a look at this. The logic there is similar. I'm just fetching the culture that was sitting in my session data and then checking on that one variable. If you have a look at the session storage provider for table storage, I haven't looked at the latest version, but in one of the previous versions, it was the case that if you fetched some data from your session, it would do a fetch on your table storage account. So this means an extra transaction and maybe extra traffic to your storage account. If you use the second one, you just do one fetch of this data. You just fetch the data once and then use the in-memory representation of the culture instead of just refetching continuously. If you have a high-traffic website or a high-traffic application where you're using a lot of sessions, well, of course, the second one will be much better than the first one because actually it's only half of the transactions and probably also half of the traffic to your blob storage account or your table storage account that's required. So developers, they impact costs. Everything a developer writes may have an impact on the costs. So it's important not only if you're architecting a solution or architecting a new application, you should also have your developers aware of the costs of the code they are writing. And it may be fun if you're writing code for Windows Azure, for example, to do a code review once in a while and just give them the bill of what the bill would be between two different statements of code. So I also tweeted this morning, I don't know if you can read them, for some questions, because I know Belgian audiences maybe, well, not often have questions during the session, so I received some questions. First one there was, is there a way to see what the size of the storage is? So if you have a deployment running on Windows Azure, and you have blob storage and table storage, stuff like that, the only way to see what amount of data you are using currently is through your bill. So that's maybe 1 month too late or 1 month later than the moment that you want to know this information. Now, there's currently no tools available to check the size of the storage account that you're using, so to check the size of all the files in all the blob containers or all the data in one specific table or all the messages in a queue. There's no solution for that currently. But what you can do, I have found Steve Mark's blog. He has written a query to just check basically all the sizes of your images. Let me just zoom that out a little bit. So you can just run a one-liner, one line of link query on your table storage or on your blob storage account and just fetch all the sizes, sum them up, and you have the total amount of storage that you have been using. Now this only works on blob storage. There's no way to do this in table storage, but it's a beginning and you can get this information. So that's possible. Okay, another question I received was, I wonder if the pricing details of all these new features that are coming out, maybe you've seen some sessions during the past few days about these new features, if those pricing is available. No, I don't know them. I have no idea about what the pricing will be. But I know for App Fabric, Clemens Vassers told me yesterday that they will be releasing a new commercial availability of the new App Fabric service bus at the end of April. So that will possibly be today or tomorrow that those prices will be available. So not the best answer, but it's the best I can give you. Then another one. Are there any special pricing options for people that want to host their blog on Windows Azure, for example? Well, the pricing option you have is basically creating an account and uploading your blog, hosting your blog in there. Now, there's an interesting one. I noticed on the chairs there's a paper telling you that you can just register a free Windows Azure pass. This will mean that you have 1 month of free instances on Windows Azure. It's limited, but you have a few free instances that you can use to experiment, to upload your deployment or your blog to Windows Azure and try it out. Another one that you can do is just follow some steps, which I'll cover after the session takeaways. So cloud pricing is more complex than, it's not more complex than regular data centers. It's different. You have different metrics in play, and you should consider all these different metrics when building your application. Quality impacts costs, and Windows Azure has certain costs, like the transaction count, for example, to, it's not much, and if you are, economic about using those transactions, you are probably also writing good code. So there's costs in Windows Azure that are basically preventing you from writing bad code unless you have a large amount of money. So the Windows Azure pricing model can improve your code quality if you consider all the details of the pricing model. Okay, if you want to start with Windows Azure, there's the free Windows Azure passes, but if you want to host your blog, for example, on Windows Azure, there's a trial offer, there's an MSDN offer that you can use. Just register for it. You have some, while limited, extra small instances, but for most blogs, I think this will be enough, and it will give you a feeling about how you can work with Windows Azure and how you can play with Windows Azure. Individuals, you can get a free one through the Windows Azure Pass, or just go to the Windows Azure site and register for the free trial. It's a few months of storage and compute power that's available for you. It's pretty simple to start with Windows Azure. You can just register for a subscription, download all the tooling, and then if you go to azure.com, there's actually a lot of tutorials, video tutorials about all the stuff that you can do with Windows Azure and how you can do it. Also, another interesting point is Steve Marks' blog, so blog.smarks.com, who is one of the team members on the Windows Azure team, and he blogs like twice a week about something he's exploring and really all the edge cases. So, for example, hosting Ruby on Rails on Windows Azure. Really interesting blog. Steve does also the Cloud Cover Show, which is a weekly episode of a video cast where Steve has a guest and they explore some possibilities in Windows Azure. So one of the recent sessions showed you how to make, for example, Facebook's like button in a scalable manner. So to have, a trustworthy amount of clicks on that like button, but distributed across different instances and still being accurate. So really interesting to have a look at. With that, another small commercial for our Windows Azure user group. We have our next event coming in May. If you want to know more about the internals of Windows Azure, to see what's under the hood of Windows Azure, come to our session. Feel free to register on azure.be. And, join us. It's an interesting session, so really worth your time. With that, I thank you for being here, and I hope you enjoy the rest of the day. Thanks.